Cost and business finance can be related in calculus. Money. Money is an important thing we need today to buy our needs and wants. Also remember the marginal cost is the change in total cost resulting from one unit change of production. This is related to calculus by computing the total cost function. Example, find the total cost function in the marginal cost function for a commodity is given by c prime of x equals 3x squared plus 4x plus 5, where x is the number of units produced and an overhead cost of 1,000 pesos. Find first the antiderivative of 3x squared plus 4x plus 5. c prime of x equals integration of 3x squared plus 4x plus 5 dx equals x cubed plus 2x squared plus 5x plus 5. From the given, our k equals 1,000 pesos, so the answer is x cubed plus 2x squared plus 5 plus 1,000.
Here is a metal bar that is used for building structures and establishments such as houses. It is included in volume of solid revolution. This is the bar, and let's see what will happen if we rotate the bar by pi. If the bar is rotated by pi, it will result to a complete circle. B equals integration of b in a, y squared dx, where y is the equation of the shape of curve.
Hi, this is related to distance, velocity, and acceleration. Using integral calculus, we can calculate the distance and velocity of moving object, especially the motorcycle. We can find the distance by integrating the velocity, while we can find the velocity by integrating the acceleration. Example, if the acceleration of the motor is equal to 2t minus 8 meter per second squared, what is the velocity of motor? Then, we will integrate the velocity. B is equal to integration of 2t minus 8 dt. Then, it is equal to t squared minus 8t plus k. If our t is equal to 0, and b is equal to 0, and k is equal to 0, our velocity is equal to t squared minus 8t meter per second squared.
Here in Sitio Aquino, Poblacion 2, Calatagan, Batangas, there are long small hills that are useful in preventing erosion and flooding. This can also be one of the attractive and relaxing place here in our barangay. I am Laarni Catalan from BE 1201. I realized that this hills is connected to mathematics, especially in calculus, because of its shape, which is the bell shape that is included in the area under a curve. But how can we find the area between curves? We can calculate the area by integrating f of x dx. Our upper limit is b and lower limit is a. Area under a curve are formed with the function of two vertical lines and horizontal axis. Their values can be calculated by evaluating the definite integrals of the function with respect to vertical bound. For example, find the area of region if that hill is bounded by y is equal to 3x minus x squared and the x-axis. Then copy the given y is equal to 3x minus x squared. Then factored it is equal to x, open parenthesis, 3 minus x, close parenthesis. There x is equal to 0 and 3 minus x is equal to 3. Then integrate 3x minus x squared dx. And use the formula x raised to n plus 1 over n plus 1. So 3x squared over 2 minus x cubed over 3. Then substitute the upper limit, which is 3. 3 times 3 squared over 2 minus 3 cubed over 3. Then substitute the lower limit, which is 0, is equal to 0. 27 over 2 minus 27 over 3 minus 0 is equal to 27 over 6 divided by 3, which is their lowest term, 9 over 2.
Hi, I am James Katapan, and I am here to explain the connection of wires and extension to calculus. The next one is the material that serves as the passageway of electricity to produce a power. This wire is related to calculus because it used in integration in calculating and determining the exact length power cable needed to connect to stations that are far from each other. Here is an electrical circuit, and between these, there is an electron with a charge of Q1 and Q2, where the x is the distance. I'll show you the example formula. The work can be calculated by integrating the force between two charges. So that's all. I hope you enjoy and learn to my short discussion about the connection of wires and extension to calculus.
Hi, I'm Charlotte Teclaro from BE 1201 and I will discuss the relation of leap to calculus. Here is a leaf which we can find everywhere that is also connected to calculus. It is connected to calculus by finding the area of the leaf using the integration of the upper curve, which is the y sub 2, and the lower curve, which is the y sub 1. And the area of the shaded area is equal to y sub 2 minus y sub 1. Using the formula, area is equal to the integration of y sub 2 minus y sub 1 dx with respect with b to a.